Hello children, how are you all? Now it's time for us to get into the next part. And what is the thing that we are learning, children? So we are talking about is matter around us pure? So in that we have learned many things, children. And in the last part we have learned about separation of mixtures. And that the last thing that we have learned was separation of mixtures by what is called as fractional distillation. So we have seen the utility of fractional distillation, children. And what is the utility? That is for fractionation of petroleum. That is fractional distillation of petroleum produces so many components of the petroleum called as fractions. Second thing, we have learnt about we have just taken an idea that fractional distillation also can be used to separate the components of our air, that is oxygen, nitrogen, argon, carbon dioxide, right? Okay, so children, in one way we have learnt, right? So but now we will just look into the details of something very essential, right? What is that? So now I'm to ask you a question. So when we feel thirsty, what do? So naturally the response, your response would be we will drink water. Very good, you are right. Okay, we need water for many purposes, right? Okay, what is the thing? So when you were small, you learned water is used for washing, cooking, this and that, drinking. But I will tell you one thing. So can you drink any kind of water so that is available to you? Will you do it? No, you will not. Why? Because the water that is got from anywhere, like ponds, rivers, etc., that's all contaminated with so many soluble salts and debris or decaying material like paper or leaves, decaying leaves. And apart from that, there will be dust, dirt. And third thing is the invisible danger, the particles, particulate matter, okay, but the invisible danger is the living material that is there. That's the bacteria, viri, and the protozoan things, entamoeba, histolytica, that's a protozoan, usually present in the dirty water. So the water which is there in rivers or other things. So all these children are not good for health. The salts may disturb the body functioning. The physical organs will be disturbed if those salts are entering our body. Second is the bacteria and harmful microorganisms. They cause diseases and loss of life. So children, what we have to do is before drinking that water, we should do something. What is that? That is called as a purification of water. So children, it is necessary for us to purify to avoid salts. Then next, remove the sediments, the dust, the colloidal fine particles that are floating in, and then next also finally remove all the presence of bacteria and cysts or amoebic cysts. So children, these are the things that are done during purification before the water is consumable or potable. So children, so we'll today learn about purification of water. We learn about purification of water, right children? So what are the steps involved in purification of water? So what is the first thing, children? From the reservoir, water comes to a tank called the sedimentation tank, and there sedimentation is done. Sedimentation. Then next we have coagulation, that is removal of the suspended impurities if they are very fine and can't be sedimented. That is by coagulation. Then next, after coagulation, we have another process actually which we should discuss. That's called as flocculation. And then next we have the filter bed and filtration. And finally we have what is called as the killing of the bacteria, the chlorination and the microorganisms, the chlorination. And finally that water which is cleaned will be sent to your home. So children, these are the different steps involved in the process of purification of water before that water is sent to us. So children, we have the diagram here. You can see the process one by one how it is done. We see the extreme left, the water is coming from the reservoir, entering into a tank where it's a very large tank, children, and that tank it has water pumped from the reservoir and allowed to settle, and this settling is done somewhere between 6 to 12 hours, and during this time the suspended particles or dust, debris, anything that gets settled, because that is denser than water. So this denser material will settle down, and the top water that will be the top. Above that the water is just allowed to flow like that, and that goes into the next tank. So children, this dust which is settled will be dense, and that can be separated and used for what we call as manure in the fields for plants, right? Next we have the next step. What is that? That is the sedimentation is done, and then next one we go to what is called as coagulation. What is coagulation process, children? What is coagulation process? So this is the process where we eliminate the fine particles which are still there. So those particles are there, like very fine particles of colloidal type, or very fine dust particles which were not able to sediment because they were not denser, they were less denser, and they were just getting into the water along, and they are just the suspended impurities. So removal of suspended impurities is the second part. The first part is sedimenting of the heavier or denser material. The second part is removal of the suspended impurities. Now how is this suspended impurity going out? So we have to force them to settle down. How do we do it? For this purpose there are some substances which are called as coagulants, like alum, potash alum, then a ferric chloride. These substances they are added as solution into the water that is taken in this tank to settle that water, the particles which are suspended. So how is this done? Well, the moment you add this coagulant material like potash alum and ferric chloride, what happens, it mixes. So slowly it is turned. As it is turned, the aluminum sulfate, the material that is there in the potash alum, usually that is the chief component. This aluminum sulfate, it reacts or it combines with those suspended particles and brings them closer and gels them together and forms a coagulant, a big mass. Okay, and while this is getting coagulated, the very fine dust particles also get adhered to these, that is, they stick to these and results in the mass of those coagulant particles increasing, and due to that massive increase in the weight increases, that becomes denser, and result is they gradually settle down, and when after a certain time most part of that suspended particles will settle down because of this alum or the coagulant. So children, we understand now the second thing that we have done is we have settled the suspended impurities from water, so they get settled. Okay, right now again the surface water over that will be taken into another tank. There's a very big tank which is called the filter bed filter tank, and this filter tank it has layers of materials. Now the materials which we use in this filtration tank or filtration bed are: one, the topmost layer is having fine sand. The next, below that fine sand, there is coarse gravel, and below that coarse gravel or stones we have bigger stones. Sometimes also we have activated charcoal. Now these are the three things which are there. Now when the water comes and falls into this, what happens is there are still, if any particles which have not gone out of water or not formed the coagulated and settled down, those very fine particles, when allowed through these or when percolated, when water percolates through these filter bed, the layers of the filter bed, gradually those particles they gets stick to the coarse sand or the fine sand, the next coarse sand, and the next is the stones, and eventually the water which comes out will be cleaner to look at. But children, what is the use of activated carbon here? So children, activated carbon also is used. Activated carbon, it has the ability to take out the smell. So what is clean water? So you know, when clean water is water which should not have visible impurities, and at the same time it should not have any foul smell or bad smell. So children, it is necessary. Filtration doesn't mean only removing the particles but also removing the smell. So the activated carbon which is there at the bottom, that will also remove the smell. So children, this way the smell is also removed. And now children, the water which has come out is having a clarity and also odorless. That is, it is not having any odor, it is odor free. But one thing is there, children, it is not free from one thing which we have discussed. What is that? We have removed dust, but there is still something which is invisible. The most dangerous thing that is still invisible, they are fine microorganisms. What are those microorganisms? They are the bacteria, the viri, and the protozoans. So these have to be removed. How can we remove? So we can't employ what I call such a very fine filters to remove. Their microscopic filters are not there. So what is the way? So the only way is to kill them there. So how can we kill them? So the killing process is called as disinfecting of water. The final process of disinfection is done by using what is called chlorine gas. So we take this filtered water into a container or tank, and that tank is pumped. So chlorine gas is pumped through that tank. What will happen when chlorine gas is pumped through the tank? Then what happens was, this chlorine gas has the ability to kill bacteria. So they will kill, that gas will kill bacteria, viri, and microorganisms, and almost all the microorganisms which can cause any diseases will die. And the result is we have water now, dirt free, sediment free, then suspended impurity free, then next finally we have, it is odorless. The most important thing is the bacteria or the virus or what we call as the microorganisms are also killed, and now we have water which is worth consuming or consumable, and that water we call it as potable water, and that comes to your houses which you will be able to use. So children, this is how the process of cleaning or purification of water is done. So children, now you have followed this. Now children, I will just recapitulate what we have learned. So what are the different processes that we have gone through? The first one is sedimentation. The next is allowing the suspended particles to be cleaned. Then next one, removal of the suspended impurities. The third one is filtration. Then next we have chlorination, and finally we have supply of water. That's very correct. Children, now I want to tell you something else. Odor removal also is a part of this process, but now children, chlorine gas, not only chlorine gas is used for killing these bacteria. For your information, there are other things also which can kill this bacteria. For your information, the other things that can be used are ozone. So you know what ozone is. Ozone is a type of oxygen, but a little different from it because it has three atoms in each molecule of that ozone. And this ozone, it has now when it is passed, this ozone breaks to become oxygen, and also oxygen which has two atoms and one nascent oxygen. This nascent oxygen also is very rapidly oxidizing ability. It has rapidly oxidizing ability and just oxidizes the material that is there, the bacteria, virus, etc. In that, they just get dissolved, you can say, are killed by the nascent oxygen. The other thing that we can use in order to kill these bacteria is the ultraviolet light, somewhere around 300 to 400 nanometer of wavelength light. The ultraviolet light, when the water is exposed to that light can also kill the bacteria. How is this done? So children, bacteria and vira are so small, they are microorganisms. They have what is called as RNA and DNA. This helps them to replicate or reproduce quickly. If we destroy this, the production or reproduction ability of the bacteria and vira will be killed. So ultraviolet light will do the same thing. That is, ultraviolet light exposed water that goes into the water and destroys the RNA and DNA of these bacteria, viri, and microorganisms, and results in killing them. And the result is you are getting purer water. So there is one more thing, children, which is something which is not out of context, but it is also one part, one type of what we call as a purification process. What is that purification process? That is called as aeration. So on very hot, when it is the water is pumped up into the air like a jet or a fountain, and the sunlight falls, that is also one method of killing the bacteria to some extent before chlorination or the other purification process are done. So this process of throwing out water into air like a fountain and exposing that to sunlight also can kill bacteria, and that process we call it as aeration. So children, thus we have concluded what is called as the process of purification of water. Hope you have enjoyed this part of the lesson. Thank you.